Okay, so this is going to be a one-take introduction to ZFS on Unraid, trying to cover as many aspects of it that I wasn't able to find in the documentation. It's a fairly new feature. As you can see, we're running Unraid 6.12.3 RC3. This is just a virtual machine that I've created some virtual drives. It's really good for being able to test different combinations and figure out whether ZFS might be a suitable replacement for using the main Unraid array instead of using a pool. So what we're looking at here is my Unraid instance has one disk. I've just got one disk of 107 gigabytes allocated to the array. The array is currently running. Obviously got the flash disk, which is that USB stick that Unraid is running on or is loaded from. And I've got a whole bunch of unassigned devices. So just to test different combinations, I think I've got 4 10.7 gigabyte drives and I've got 10 107 gigabyte drives. So let's go through the process of just creating a simple ZFS pool. First thing we have to do is stop the array. Give it a second while it figures that out. Okay, and then we're going to create a new pool. We're going to call this one ZFS. And we're going to give this one 4 slots. Here we go. So I'm going to allocate now all of the 10 gigabytes, which luckily for me are all organized at the bottom. So first of all, if we look at just one drive and then click on the link, change it to ZFS, we can see that it's a single one device ZFS. Super. Go back, add another 10.7 gigabyte drive. Have a look at this top drive as well that's controlling the pool. ZFS, right, so now we can do a RAID 0 of 2 devices or a mirror with one group of 2 devices. Okay, let's keep going. Add a third 10.7 gigabyte. Now what can we do? So when we select ZFS, we can now do what we did before, RAID 0, mirror, or RAID Z, which is going to give us redundancy using parity of one device. Great, we can see one group, 3 devices. Let's keep going. Add that fourth 10.7 gigabyte drive. Fantastic. Let's have a look at what our options are now. When we select ZFS, we've got RAID 0, mirror, RAID Z, and RAID Z2. So I can have redundancy of 1 drive's worth of parity, RAID Z2, 2 drives worth of parity. With 4 drives, effectively, we've got the space of 2 of the drives and the other 2 drives worth of capacity is going to be used for parity. So I can now support 2 drive failures. Let's set this one up. Because it's 4 drives, common, the most efficient would be a RAID Z block of 4 drives. Okay, we've applied that. We can see this is all ready. We're going to now start the array. Give it just a second to start up. Great, so we're getting a message that it's an unmountable file system. We're going to have to accept and format this. Again, this is just the initial configuration. Give it just a second. Just formatting now as ZFS. Done. Great, so we've now got a ZFS set up as a pooled drive. We're going to click on the top node. We can see, yep, great. So it's RAID Z, one group of 4 devices, and we can see here in this pool status that we've got a pool called ZFS that is online. There's a RAID Z1, and that we've got 4 devices. Great, so this is working. I can now use this, have my media, have shares now putting data on this device. It's all working. I can see if I click over here, it's there. I can start putting things on it. Great. So the next thing that I was kind of concerned about or wanted to know more about was what happens when things go right and wrong. And ZFS is a fairly new file system to me. I've used it a little bit with TrueNAS, but I've not used it extensively. I went over to Unraid and have utilized Unraid's file system using XFS and with parity drives. Been very happy with it for as a media server. So I'm looking at all these drives. I've got 10 drives. What does this mean? So if this is a real test, if I was going to migrate my array over to a ZFS pool array, what could I expect? So first thing is to stop the array. And we're going to create a new pool. And we're going to call this ZFF. Going to give it 10 slots because that's the number of drives we have available. You can always expand the number of slots you have. It's kind of irrelevant. You can see here that I can change it to whatever I want. The maximum devices per pool appears to be 60, which is quite a high number because the array, I think, limits to 30. Yeah, it does. So you get twice as many disks per pool with using pool devices, and you can have multiple pool devices. I'm not sure what the limit of how many total devices and how many total pools you can have. Feel free to comment below. Fill me in. So we'll start off with allocating 5 drives. Of course, we've got 10. Okay, there's 5 drives allocated, just like before. Click on the one at the top, select the system. We're going to, again, have redundancy. Perfect. I'm going to apply that. I'm going to start the array. Great, same issue as before. Just got to accept and format this pool. There it goes, it's formatting. Done. So we've now got, just as before, another ZFS formatted pool device. And this is all working great. But imagine I want to extend this device. This is something that caught me out earlier on, but it's probably just down to my knowledge of ZFS and being so familiar, so used to Unraid accepting single disks and disks of different sizes. So what I was doing was stopping the array. And then when it catches up, let's try to allocate just an additional drive. And this doesn't make sense. If you know ZFS, you know how the VDEVs work and the fact that you have to have multiple VDEVs. So with, again, probably just ignorance and caught out by the fact that Unraid's array is so convenient. So I was thinking, right, so I've got 5 disks already. I'm going to add an additional disk to extend and expand my pool device. Let's see what happens. Right, so I get a wrong pool state, invalid expansion. What this means is that I can, because I've started this pool device with 5 devices, I can now only extend it 5 devices at a time. So even if I do 4, it still won't work. I've got to do at least the same number that we've got in this first part. So start, see, still invalid. But the moment I add the 5th, so I've added the same number of disks that I already have already. It'll start. And I could then add another 5 disks and another 5 disks and just keep going all the way up to 60 devices. The array is just starting. Perfect. Now, because I'm adding disks to an existing ZFS pooled devices array, it's not asking me to format individual devices. It's just allowing me to add them and they'll be cleared as part of them being added. Great. So this is expanded. So now I have one pooled devices array with 4 10 gig disks. And now I have another pooled devices array of 10 107 gigabyte disks. And this is all working great. I can use this device. No concerns at all. If I click on the top one, which seems to be acting as a kind of master node in terms of just how the interface works in Unraid, I can see my pool labeled ZFF is online and it contains the 2 VDEVs. So I've got this first one, which was the first 5 disks that I added that are in a RAID Z1. So I've got 1 device worth of redundancy should one fail. And now I've got a second VDEV, which is another RAID Z1. And I can keep doing this and adding disks in collections of 5 in this case, because the first one was started with 5. I believe that future VDEVs that I create don't have to be 107 gig disks. They could be any size, but it's recommended that it's the same size across the VDEV. So I'd have to add 5. I had 200 gig drives. I'd have to add 5 200 gig drives if I wanted to. But this is the basics. There's no errors. It's all online, looking good. I can click the scrub button, which carries out a scrub activity. So in my mind, I'm thinking this is working quite well. I'm feeling quite happy that I'd want to migrate my main array across to a ZFS backed solution. But what happens when a drive fails or dies or becomes, unplugged? How does that all behave? So I'll go through and show you what happens there. So first thing I'll do is I'll remove one of the disks on my virtual machine. We're going to remove disk 7 by the looks of it. So that's been removed from the virtual machine. Just the way that VirtualBox and how it exposes devices are going to probably have to restart in order to get this to show up. So we're going to reboot the system. Just going to pause the video and resume it as soon as the array is back. Okay, so we're back and it's detected that we're missing a disk. It's saying that this is the name of the disk that's gone missing. I can go, this is a physical server. I could go hunt and find what was going on with that disk, whether it had failed or become unplugged, etc. But down here, it still allows me to, well, interesting use of some terminology. So it says it's missing a cache disk. That's probably because pool devices were originally used for cache disks, but they've extended it in over multiple versions to now include the ability to create additional arrays effectively. So I'm going to go ahead and start it anyway, even with the disk missing. Okay, so the array did start, and I can see that this is degraded. It tells me that one or more devices has been taken offline. It's still functioning, but it's degraded. Great, and it tells me which one is missing here. It says, right, so it's degraded as part of this VDEV. So quite a lot of useful information. It's going to help me track down what which drive I need to look at. Super. So that's all great. Now I'm going to stop the array. And if I was to simply reattach this drive and it's now available again, I'll show you what that looks like. Getting ahead of myself with the time it takes for the array to start. There we go. So if I was to find the device which is missing here and simply plug it back in and reattach it, then everything would be good. So if I go and do that, I'll try and do it hot swappable. Let's see if it works. So add that disk back. Does Unraid detect it? There it is. Right, so the disk is back online. Now, if I was to simply stop the array, no, maybe I'll just refresh my screen. There we go. It's just my screen was out of date. So if I was to now just click on this drive and start the array, boom, it'd be straight back up, no issue at all. Wouldn't have to do any rebuilding of the data at all. It would just, hey, the disk has returned. Now that's a different type of failure to if a disk is creating read errors and dying of of a failure. Then I'd need to swap that disk out, and then I'd have to start what ZFS calls resilvering, where it uses that parity to rebuild the structure. So if it's just come loose, unplugged, gone offline, whatever, you can simply just correct that fault and reassign the device and start the array, and it'll work instantly again with that issue. What I'm going to do is test, just so you can see what happens when we actually destroy the data on the disk. So this would be simulating a failed drive, kind of natural causes, and then replacing it with a new drive. So I've inserted my brand new clean disk after having a pretty typical disk failure. There we go. My disk is completely empty and available to be allocated. So now I'm going to allocate that disk, and I'm going to start the array. What we should see is the ZFS system realizes that there we go, got a notification, realizes the disk is new to this array because it's a fresh disk, and starts what's called resilvering, which is rebuilding the data structure again using the parity data. Now, hopefully I can click on this in time. Oh, it's happened so quickly that because there was no data on the array that we missed it, but you can see that it's resilvered. So if we had data on the array, it would take a bit of time whilst it resilvered and rebuilt the structure of the array. But as it's an empty array, it was instant, but it will take anywhere from minutes, hours, days, depending on how large your array and how much data is on it. It also depends on the specific configuration around your VDEVs, what RAID Z level you are, but it's worked. So I've recovered from two scenarios that we've shown you. One is just a device becoming unplugged, which happens more than you'd think with a consumer level operating system like Unraid, where people sometimes use external disks. So we've recovered from that by simply reattaching and starting the array again. Fantastic. And we've also demonstrated what happens and what the experience is like when you have to replace a failed drive with a new drive that's new to the array. Obviously, the higher the RAID Z level, the more redundancy you have. So a RAID Z2 will provide you similar to what Unraid would have as two parity drives. You're going to be able to have two parity drives worth of, or two drive failures before you are going to be unable to recover the ZFS system. So again, this is all very new to Unraid. Between the forums and other YouTube videos, I hadn't quite found anyone that had walked through what is the experience for someone that's familiar with Unraid. What does this now look like when you want to use ZFS? And for me, I'm really interested in utilizing this new file system to Unraid, but also to utilize its self-healing, its sort of bit rot prevention and protection that it offers, especially as I'll be storing things mainly for archive reasons or large media files for a long time where they won't be used or accessed, and bit rot could potentially set in. As I understand the way that the self-healing works is when I go to read the file, if any corruption or bit rot's detected, it's going to use that parity to resolve it automatically. And that's something that you don't get with any of the file systems when you're using the main Unraid array, because each disk has its own file system. Even with parity drives turned on, you're not getting any ability to resolve bit rot. And unfortunately, you're only able to use the parity to rebuild when an entire drive is failed or replaced. Hope this has been useful. Shoot a comment if I've got anything wrong, you want to correct me, or if there's anything else you'd like to see. Thank you very much.